Have you ever pondered on the importance of securing software? In today's digital world, where technology is intertwined with virtually every facet of our lives, cybersecurity is no longer a luxury. It's a necessity. Imagine a world where your personal, financial, or even health information could be accessed and manipulated by malicious actors. Terrifying, isn't it? That's the reality we face if we don't secure our software. Every time we use a computer, a smartphone, or any digital device, we're interacting with software. Software that, if not properly secured, could become a gateway for cybercriminals to wreak havoc. The potential risks and consequences of not securing software are staggering, from identity theft and financial loss to a breach of national security. As we delve deeper into this topic, we will learn why it's vital to protect our software and the strategies we can employ to do so. So stay tuned, and let's navigate the world of cybersecurity together. Now, to protect our software, we first need to understand the threats out there. Let's start with phishing attacks. These are deceptive tactics where adversaries use HTML and JavaScript to create misleading links, luring users into malicious sites. Next is cross-site scripting, or XSS. In this type of attack, adversaries inject malicious code into websites, which then execute on a user's browser. Imagine the havoc when a seemingly harmless site turns into a hacker's playground. Then we have code injection. This is where adversaries insert code into software to carry out unauthorized commands. It's like a thief sneaking into your house and taking control of your security system. Buffer overflow attacks are another threat. Here, excess data spills over into adjacent memory space, causing unexpected behavior. Lastly, we have remote code execution, which allows attackers to run malicious code on a separate computer. It's essentially remote control, but for your computer. By understanding these threats, we can better equip ourselves to guard against them. Understanding the threats is just the first step. Now, how do we prevent these cyber attacks? The answer lies in a multi-pronged strategy. Firstly, we need to secure our databases. This can be achieved by using prepared statements. They separate data from commands, preventing malicious code from slipping through. Secondly, always validate user input. This means checking that the data entered by users is what you're expecting. For example, if you're expecting an email address, ensure that the input matches the structure of an email address. This simple step can prevent many forms of code injection. Lastly, consider adopting open-source software. With a global community of developers constantly scrutinizing and improving the code, security vulnerabilities are often identified and patched quickly. Remember, cybersecurity isn't a one-time event, but a continuous process of vigilance and adaptation. These strategies, when implemented correctly, can significantly reduce the risk of a cyber attack. Now that we know the threats and prevention strategies, what tools and resources can we use to secure our software? One of the key resources is bug bounties. These are programs where organizations incentivize the discovery and reporting of software bugs, particularly those involving security vulnerabilities. By crowdsourcing their security, companies can harness the power of many eyes scrutinizing their code. Then there are CVEs, or common vulnerabilities and exposures. These are publicly disclosed security flaws in software that can be exploited by attackers. With CVEs, developers have a central repository of known vulnerabilities to help them build more secure software. We also have scoring systems like CVSS and EPSS that help developers prioritize the handling of various vulnerabilities based on their severity and exploitability. Finally, let's not forget the importance of server-side validation. While client-side validation can provide a good user experience, it's limited in its security capabilities. Server-side validation is crucial to ensure data integrity and security. By leveraging these tools and resources, we can make our software much more secure against potential cyber threats.